Good morning, everyone. In this video, I'm going to go over Wednesday's page of the Week 18 packet. All of these questions that we go through are going to be reviewed for the test tomorrow. So for the do now, I'm asking you to write down all of the formulas we have used in the circular motion unit. You can take out your reference guide and see what you can find. There should be 4 of them. And then write down in which formulas does R stand for radius. So it is actually 2 formulas that we have. And then in which formula does R stand for distance between centers. So you can pause the video here and fill in your do now. These are the 4 equations we've used so far. The one that I've highlighted in red is something that we talked about in class. We combined these 2 equations to make this equation. You're definitely going to need this on the test, so if it's not already written on your reference guide, you should add that in. In which formulas does R stand for radius? That would be this one, AC equals V squared over R, as well as this one, FC equals MV squared over R. So in both of these cases, R stands for radius. And then in which formula does R stand for distance between centers? That would be this formula, FG equals GM1 M2 over R squared. So this is the distance between usually a planet and a sun, or a moon and a planet, something like that. Alright, so the following information refers to questions 1 through 4. We have Io, which is pronounced Io, is one of Jupiter's moons discovered by Galileo. Io is slightly larger than Earth's moon. The mass of Io is 8.93 times 10 to the 22 kilograms, and the mass of Jupiter is 1.9 times 10 to the 27 kilograms. Jupiter's radius is 5.64 times 10 to the 7th meters. The distance between the centers of Io and Jupiter is 4.22 times 10 to the 8th meters. My recommendation is that you use cubes to annotate your questions. It can help especially to pick a formula, which can be the most challenging part of these questions. So, question 1 says, calculate the magnitude of the gravitational force of attraction. I am looking for gravitational force. So I'm going to write FG equals question mark, that's what I'm solving for. And then I want to list some of the values that I was given. So if you do go through and annotate, you can kind of just list out all of those numbers that you circled. I would start with the mass of Io is 8.93 times 10 to the 22. And I'm going to label that M1. It would also be fine to label it M2. So it just shows up first, so that's why I'm doing it like that. 8.93 times 10 to the 22 kilograms. The next thing they give me is the mass of Jupiter, so I'm going to have that be M2. So that's 1.90 times 10 to the 27 kilograms. They do give me Jupiter's radius. I am not going to be using that because in this formula, I kind of already know that I'm using this formula here, Fg equals Gm1 M2 over R squared. And so R doesn't stand for radius, it stands for distance between the centers. And the distance between the 2 centers is given to me 4.22 times 10 to the 8th meters. The other variable in this equation that I haven't written down yet is capital G. You can find that on the front page of your reference table, 6.67 times 10 to the negative 11 newtons meters squared per kilogram squared. So this is how I've listed all of my variables. I would say pause the video here and try the substitution, and then you can see if you were correct. Alright, so to get full credit for this question, you need to have your substitution shown like this, plugging in each number with the units. Make sure you don't forget the squared. Ideally, you have parentheses around each number with its unit to separate them, and the squared goes outside the parentheses to show that you do plug it into your calculator. This middle part is optional, but it might help you kind of organize things. And then your answer needs to have the exponent and the units. So if you got 6.35 times 10 to the 50 something, that would be considered wrong. It should be 6.35 times 10 to the 22, and it has to have newtons. If you did get 6.35 or 6.348 or something like that, but you got a different exponent, most likely something was missing parentheses, or maybe you forgot the negative here. Right. Question 2 says calculate the magnitude of the acceleration of Io towards Jupiter. So I am looking for acceleration. That's going to be my question mark. You can use centripetal acceleration in this case, although you could just kind of think of it as regular acceleration, and either one would be fine. But specifically, we do have a formula for centripetal acceleration. We have two of them. We have Fc equals mac, and then we also have ac equals v squared over r. The easiest way to see which one you should use is to list out what you know, or to just kind of, the most common one is to see if you have velocity and radius. So we don't have velocity. We don't know how fast Io is moving. We cannot use AC equals V squared over R. So I'm going to go with FC equals MAC. I know I'm solving for AC. I do have FC. That's what I calculated already in the last question. So that's going to be 6.35 times 10 to the 22 newtons. And I do know the mass. It's specifically the mass of Io because they're saying acceleration of Io. So the mass of Io was this number, 8.93 times 10 to the 22 kilograms. So that is all of the information that I need. Go ahead and plug these numbers into the equation and pause the video and see if you can do it on your own, and then check your work. Alright, so this is what I plugged in to my equation. So I've got my 6.35 times 10 to the 22 newtons equals 8.93 times 10 to the 22 kilograms times AC. At this point, just divide by 8.93 times 10 to the 22 kilograms on both sides to get AC by itself, and you should be left with 0.711 meters per second squared. Make sure you practice plugging this into your calculator so that you get the correct number. If you get like 7.11 times 10 to the something else, maybe times 10 to the 40 something, that means you forgot to put this number in parentheses when you were dividing in your calculator. That is very important. Question 3 says, name one change that would increase the gravitational force between Io and Jupiter. Here, let's just look at the formula just to reference it. So we've got Fg equals gm1 m2 over r squared. If we want to increase the gravitational force, there are technically two ways to do that. We can increase a mass, or we can decrease the distance between them. Either one would be fine. It could be increase mass of Io, increase mass of Jupiter, or decrease the distance between them. And that is because mass 1 and mass 2 are in the numerator, so it's a direct relationship. If I make mass 1 bigger, force also gets bigger. Name one change that would decrease the gravitational force between Io and Jupiter. So it's the opposite. We could decrease the mass. You could also increase the distance between them. Either you don't have to write both, just either one of these would be fine. And also for question 3, decreasing the distance between them. So if you want to make Fg bigger, you could increase something from the numerator or decrease something in the denominator. We've spent more time in class talking about increasing these variables, so that may come more naturally to you. If we increase mass 1, Fg increases. However, if we increase r, Fg will decrease. So that could be your answer, increase the distance between them, or increase r for question 4. The next part refers to questions 5 and 6, and then we're looking at this diagram. So it says a 1.5 kilogram cart travels in a horizontal circle of radius 2.4 meters at a constant speed of 4.00 meters per second. Calculate the magnitude of the centripetal acceleration. When you're annotating, it may be helpful, instead of underlining the entire question, to just underline centripetal acceleration. That is the shortest way of saying what we're looking for. We do have 2 formulas for centripetal acceleration, so it may help to list our variables. I'm looking for AC. That's going to be my question mark. I do have the velocity is 4.00 meters per second. I also have the radius, which is 2.4 meters. I also have the mass. 1.50 kilograms. I am going to be using AC equals V squared over R because I have V and I have R. And you don't have to worry about the mass. It's there, but you don't actually need it for question 5. So this is what I plugged into my equation, 4 meters per second squared divided by 2.4, and I got 6.67 meters per second squared. Question 6, we're finding the magnitude of the centripetal force. Once again, we do have 2 options for that, FC equals MAC. We could also use FC equals MV squared over R. And either one would work here because we have mass right here. We have AC, we just calculated that. But if you wanted to use MV squared over R, you have those. You have mass, you have V, and you have R. I'm going to use FC equals MAC. I know I'm solving for FC, so that's my question mark. Mass is given to me. That's 1.5 kilograms, and AC is what I just solved for. So that was 6.67 meters per second squared. And this is what I wrote down for showing my work, the formula. The numbers that I'm plugging in, 1.5 kilograms times 6.67 meters per second squared, and that equals 10 newtons.